consumption of oil through time as well. Every single year we have done nothing but burn a little bit more and a little bit more and a little bit more. And now that's not centralized on one area, one state, one country, something like this, that we certainly vary, right? Different regions in the United States vary their amounts. Different countries also vary their amounts, and so on and so forth. Okay, so there's our daily barrel of oil. And to discuss peak oil, of course, remember, this is a physical principle of anything. Go back to the Snickers bar or the candy bar analogy. Eventually, you get to a point where the next bite you take out of something is lower than any amount that you had before. You're getting into the bottom of the barrel, as they say, the very end of this stuff. So this is a stacked diagram that's meant to show the reserves around the world of the fuel or of oil fuels. And green is here in the U.S. is here in green. This was also published before, I want to say, or barely into the shale oil boom of the United States. So that's not well shown on here or well documented on here. But let's be really honest, that shale boom is effectively over. And those wells are already beginning to decline. It's already getting harder to get some of that stuff out. So that was a boom and is not continuing further. So let's add on another 10 years onto this estimate, and that's what that did. Anyway, here's the U.S. It was properly predicted by King Hubbard in the 1950s that he projected by 1970 U.S. would reach essentially our peak production, which he's remained effectively correct. We discover a little bit more every once in a while, but all of that does is extend the graph in this direction. We're never moving where peak was. Then other countries who've come into the oil game a little bit later, they have offset peaks. So here's Russia. Russia reached their peak in the 1990s. You have the Middle Eastern oil here in pink that had a peak, but of course there's been more large discoveries and has almost gotten closer to another projected peak here in the future, but we would need larger fields to be discovered. So the stacked peak, again, natural gases, that's extended a little bit, but the stacked peak essentially is showing up about now, right? Again, this is a decade-old slide, about in 2010 is about when peak oil is. Okay, so whatever, don't put numbers on it. Let's just say that it was either 10 years ago or 10 years in the future. I don't really care. It doesn't really matter, and you can quibble about that all that you want. It doesn't change the fact that peak is an inevitable physical principle that does occur with this substance or any other substance. So let's go ahead and move that peak to 2030. Okay, so what? So peak still occurs, and we still decline thereafter. What I'm saying is that this is a problem because we are so inevitably dependent on this resource and all of these resources discussed that we can't think of living our lives in a different way with the population and the modern conveniences that we have. So this is a problem. We need to figure out a way to extend this part of the graph. When peak occurs, it occurs, we need to figure out a way to get more bang for our buck with these materials and to extend that further. We need to get better at using the stuff and use less. With the background of peak, there will be an end if we were just to continue burning this stuff at the rate that we burn it today. And here's the amount of gigabarrels, 1.032 gigabarrels, 1,032 gigabarrels of oil. Those are billions of barrels of oil in the known reserves that are out there in all countries, including the Saudi Arabian oil. Huge field. And then if we burn, here's the number, again, 75 million barrels per day. If we do the math there, 13,000 days or 37, about 40 years from now, if we continue at the rate of consumption that we go today, then we will be out of consumption, right? Or we will have overconsumed and have nothing left. Now, This is a diagram. Here's today's, or basically close to today's data. I guess we're closer to over here now, aren't we? And what this is showing, and all you can do is just kind of move this, but what this is showing is that if we stopped producing today, or from all those production wells that are going today, every day they're pumping out a little bit less from that tank, from the reservoir than they were the day before, right? That's, again, just a physical peak. Eventually, you deplete the reservoir. So this is what we need to offset the reservoir depletion. This is what we need to develop fields that haven't been developed. We know that they're there, but in order to keep up with our production, we need to develop those fields. We need to find more fields. We need to tap into unconventional oil, and so on and so forth. But even if we do all of those things, right, this is what we call the wedge of hope, is that we hope that we will do those things, and we'll do them in a fashionable manner to actually help us extend, not peak, but to extend the tail of that peak. I should go in this direction, the direction with the slides. So what about new discoveries, increased efficiency, and enhanced recovery? Absolutely. Those are all things that are going to help us extend that a little bit further. But there is no going around that we just need to use less of this substance, right? Of all the metals and all the things we looked at that are multiple hundreds of years until we run out of those things, oil we have under a century, right? And we really need to think about our future generations and conserving this material. Climate change aside, right? Take climate change out of the factor, right? Just to set aside for a second. Even if burning the material wasn't harmful overall to the status of the globe and global climate change, even if it wasn't harmful, we're still going to run out. Okay? So it's very serious that we need to figure out ways to conserve this very beautiful dynamic material. So Earth does have a future, positive notes, right? We do have a future forging forward, and you can find this paper there on the canvas or on my website if you're accessing it through there. So not only do we live in what's termed the Anthropocene, now this is a little bit speculative. This kind of goes a little bit further than our geologic discussion here, talking a little bit more about future and things like this. But also it's been suggested that we may live in some completely new era of geologic time called the Psychozoic. Remember, we have the Precambrian, the Paleozoic, the Mesozoic, the Cenozoic, and maybe we're at the very end of the Cenozoic, and now the planet enters a brand new era, which is the Psychozoic, or the collective minds and bodies together to sort of be a mind forest of this earth. And this is a transhumanist vision 2.0, right? I mean, this is sci-fi. This is the human potential movement in a nutshell. This is believing and knowing that people, right, through all of our various religions and spiritualities and collective consciousness and New Age thinking and all these things, that people have a lot of potential. As humans, we have an amazing amount of potential, and we are really living in that time now where we are plugging in and we're connecting globally across the globe via the internet and talking with each other and exchanging ideas. So I think this is a really beautiful way to think about each of us as individual nodes of a collective global brain. So not only the Anthropocene, but the Psychozoic evidence, Homo sapiens is the first species on Earth to be aware of itself, and not only to be aware of itself, but to look out into the local environment beyond ourselves, the solar system, and in the universe. My phone was just ringing. Sorry, I got distracted. We're the first to put these eyes to the world and to look out and to realize that we are the eyes of this planet, right? Just as the Grateful Dead quote earlier in the term, we are the eyes of the world. So those eyes of the world, as we're looking out, we're of course trying to look for other entities like us, other intelligent life. So the search for extraterrestrial intelligence, and this has been on for a couple of decades, and we would really like to know the old question, are we alone? Are we alone on this planet, in the solar system, in the universe? All of these bigger questions, and I have no need to try to attempt to answer those, but to look at what we do know and what we do think. There is a scale of types of civilizations, the Kardashev scale, that lists different types of situations, a sci-fi concept, types of civilizations. Either you're a civilization type 1, where you have control of your whole planet. We're not there yet, by the way. We're a 0.7, 0.8 something level civilization, so we're not quite to a level 1. A type 1. There's a type 2 civilization that has control of its entire solar system because it harnesses energy from its sun and distributes that across the solar system. Certainly not there yet. And the evidence suggests, at least in the Milky Way galaxy, looking at a lot of the stars around us, that there is no evidence that any of the stars that are out there are being harvested by this feature, which is called the Dyson sphere. This is the process, these are all kind of like solar panels, of taking that energy and distributing it to the rest of the solar system. And this would leave a unique light signature on the planets. After all, this is how we find exoplanets. There's been over 3,000 planets outside of our solar system discovered because we look at other suns, and as the planets transit them, they dim a little bit so we can tell there's planets around them. Well, we can't tell that any of those suns or those stars have Dyson spheres. So there may not be any type 2 civilizations out there in our galaxy. We don't know about other galaxies. Then a type 3 civilization is a civilization that has control of its galaxy, of its host galaxy. We don't seem to be living in one of those, right, where the Milky Way is being occupied like a Star Wars type of society, a galactic empire, where people are running around to every planet. We haven't seen evidence for that, even if there are, aliens in Area 51 and all this kind of junk, the flying saucers and whatnot. Even if we've been visited, we certainly are not participating in the civilization at this level, and it does not seem to be, right? We don't see any of the Dyson spheres, so our galaxy doesn't seem to have gone to that level either. So I find that really, these levels of civilization, very interesting as well. So on top of that, 2015 study of galactic mid-infrared emissions came to the conclusion that there are no type 3 civilizations out there. They're either very rare or they don't exist in the local universe, maybe further out there. What I find very interesting about the search for extraterrestrial intelligence and time is that, remember, it takes a long time to shoot light away from us and then to return a signal. So the Voyager spacecrafts that are out there beyond Pluto, out there beyond the Kuiper Belt, I think, and now out into the Oort cloud, out into interstellar space, that's about a light second away from us. So to get outside of the influence of our sun is about 1 light second. It takes a second for that light to get out of there. It's not very far, right? But that's the furthest we've ever traveled with any of our space stuff. Now that, compared to the closest star to us, is 2.5 light years away. It takes 2.5 years for a light signal, to travel there and to travel back. So say that when we began the search for extraterrestrial intelligence and we beamed a radio signal out to one Alpha Centauri Proxima, which is one of the Earth-like planets that's going around Alpha Centauri b, that's shown here. If there were people living there that had radio signals and they shot one back, it would have taken 5 years to complete that transmission. 2.5 years there, 2.5 years return, minimum. That's without them even thinking about their response, right? So communication with even our closest neighbors outside of our solar system would take a very long time. We know that there's no intelligence in our solar system, right? There's no other planets that have been messed with like ours, right, that have reached this level. And similarly, it would just take a long time to talk to any of our neighbors, let alone get there, or let alone them get there from here. Kepler 186F, 500 light years away, also thought to be within its Goldilocks zone and thought to be a habitable planet, an Earth-like planet, 500 light years away, or any of the other 3,000 I think it's over, I think it's like 3,400 exoplanets that have been discovered. They are multiple light years away from us, multiples of tens, right? Here's the system discovered last year, TRAPPIST-1, that has something like 9 or 7. It has 7 Earth-sized planets, 3 of those at least in the Goldilocks zone, the habitable zone. It's 40 light years from us. It would take us 40 years to send a beam of light there, let alone travel there. And then, of course, the light, that's all from in our own galaxy. Our nearest galaxy to us, the Andromeda Galaxy, 2.5 or 2.9 million light years away. 2.9 million light years away. So that, I might have that number wrong. I probably should have looked that up. It might be 2.3 million. Anyway, millions of light years away, the nearest galaxy to us. So sending a light signal to them, if there's anybody out there, would take millions of years, get there, and then come back. So even if there is intelligence that's out here that has reached our level, we have not technologically reached the level to be able to really communicate with them. So even if we are not alone out there in the cosmos, we are still under the ability to really detect if there's anybody like us. Just the threshold of being able to detect that is unanswerable. Okay? Now, one major thing I'd like to say about catastrophes, okay, that almost feels like kind of a anticlimactic there to reach into space after all of this, talking about how humans have, we live in the Anthropocene and how we distribute all this stuff, and to go a little doom and gloom on you. But again, there's positive notes that are here. Knowing about this is part of the solution, right? If we don't know, then we can't do anything about it. So that's why this is so positive. Over the last 50 years, 70 years of environmental movements, or since Rachel Carson's Silent Spring and becoming aware of our environmental impacts on this planet, awareness is the first step to being able to do something about it. Okay? So the dinosaurs had no idea about the incoming asteroid. We at least have a shot to detect a bolide, but right now we do not possess the ability to do much about it. But maybe as we move through our adolescence during the Anthropocene, we figure out ways where we can not only save ourselves, but we can be the stewards of the rest of the earth and save us from overall extinction like the dinosaurs had occurred. Now, that was an asteroid impact, right? Global climate change, biologically created mass extinctions. Those things are a lot harder and multi-working interparts to deal with. But a rock that's just coming towards the planet, if it's that, we can probably figure out a way to deal with that technologically, which is a new thing as far as species goes. Okay, I really like this comic, A Short History of America by Robert Crumb. Here's a nice open grassy field. Then you can see the progression, the steam train, the house, the electricity, the telegraph, the electricity, all these things building up and building up, building up until you're a full-blown city that doesn't represent anything of what it did before with the wildlife, the plains, the grass, the meadow, the trees. And we have, in Robert Crumb's scenario, we have 3 scenarios here, right? The worst case scenario, ecological disaster, right? There's the far end member. Then the far other end member is that we have this fun future of the techno fix, right? Where we're able to fix all of these problems with technology and to consume more and more metals and more fertilizers to grow more and more corn, right? Which clearly is not sustainable. So I think that we don't want this to occur. I don't feel scientifically like this is sustainable given the resources of the planet unless we really do well at harvesting solar energy, at least, and working on our recycling loops, right, and things like this. But then there's the kind of middle ground, which is this kind of more ecotopic, hippie, villagey type of thing. And this isn't the perfect middle blend, I don't think. I think that using technology we can bolster this a lot more, because clearly we have electricity and that's not going away, right? We can continue to use that for a very long time. But there's a middle ground somewhere between, between all of these. Really, we don't want to go here. We probably can't go here. Here's maybe a little too risque for some people, but there's a good middle ground using technology. There's the author John Michael Greer that a couple of years ago wrote a book called The Ecotechnic Future, blending the eco with the techno into a new age of humanity. And today's dose of violence is brought to you by author of the book Earth in Human Hands. It's a beautiful book if you're into this concept of the Anthropocene and what we are going, what we're doing, where we're going, and where we've been. David Grinspoon, highly recommend his book and material. Lynn Margulis and Carl Sagan also. Lynn Margulis was discussed very earlier in the term in the Gaia hypothesis, and then used Carl Sagan, a couple of Carl Sagan's bits of advice here today as well. So today's dose of violence and hope is brought to us by these three brilliant scientists. And with that is the end of the 10 lectures, the 10 main lectures of the Violent Earth course. And I really appreciate you tuning in for this. If you registered for the course and you paid for this, if you stumbled across this stuff some way, or if you're an old student who's just listening to this to fall asleep, listening to my voice lulling you to sleep, any of these, I'm just so happy and so grateful to be doing this and to getting this material a little bit more out there. And I'm so thankful for all of the scientists, all the giants shoulders that I stand on to be able to present this type of stuff, and all those people who've helped me get to this point. And with that, I'll add more material to this lecture course over time, and maybe eventually even change these videos up a little bit as I add more material, okay? Feedback, always welcome. Please email, please comment in these video-y things, or however, there's plenty of ways to get a hold of me, and please do. Okay, thank you very much. Enjoy your life here on this violent earth. Yeah, I'll shut it off eventually. I'm just sad to see you go.